All right. Hello. Welcome back to Curiosity Corner Live. My name's Andy. Bow ties are cool. And Momgineering the Future is here. Cedric is here. Welcome. Thanks for joining us. And as always, Momgineering the Future, thank you very much for sharing all of your experiments on social media. Absolutely amazing stuff. All right. Well, Isaac is here. Hello, Isaac. Cedric says glasses are cool. That is true. All right, so today, Leo is here. Welcome. Today we're going to be talking about a little aspect of science involving weird motion. And of course, every day at 10:30, we will bring you live science content like this. Every weekday at 10:30, we'll bring you live science content. So make sure you like and subscribe so you don't miss out. So weird motion. I have a few two concepts that I'm going to share with you. Two ideas I'm going to share with you. One is, I'll show you what the first one is because it's pretty wild. So I have a GIF here, a .gif, a video without sound, and I'll show you that right here. This is a handle spinning in space, and it'll repeat. So astronaut comes in, hits the handle, spins it, and the handle starts moving in a very weird way. Shoot, 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 shoot. We'll see that one more time. So this is a result of something called the intermediate axis theorem, or the tennis racket effect. So here's what's happening. I'll show you with this brush. It's not a tennis racket, but it's about the same shape. Anything that's shaped where it's flat on one side and it's sort of roughly T-shaped will show this effect. So here's one thing. If you spin a brush or a tennis racket or something, I have to stand up for this. That's why. There we go. All right. So if I spin this like this, then it kind of spins the way you would expect. Nothing fancy. It just spins down the handle like that. And if I spin it the other way like this, then once again, it goes exactly the way you would expect. Nothing crazy happens. But then if I spin it like this, then it starts behaving in a weird way. So I have a piece of blue tape on the top. If I spin it with the brush flat, parallel to the table, blue tape on top. Now the blue tape's on the bottom. I didn't do anything. I just tried to spin it. And it twisted in the air, just like that. So tennis rackets do this. Books will do this too. So here's a book. Rocks and Minerals, one of my favorite subjects. So it spins how you'd expect. Spins how you would expect. I put some bumper bands on it so it doesn't open up. But if we spin it this way, then you can see Rocks and Minerals is on the bottom. Now it's not. Rocks and Minerals on the bottom. Now it's not. And of course, my ponycorn does the exact same thing. Spins very wildly if I spin her down the intermediate axis. So when I talk about intermediate axis, if you look at a brush, you can imagine a few different lines going through it. So there's a line going down the handle through the end of the brush like that. That is one main axis. And then there's another line going this way. And then there's another line going this way. A while ago, I talked about the 3 dimensions. It's pretty much the same thing. Down the length is one axis or line that something can rotate around. There's another line or axis, and then there's another line, length, width, and height. So if you spin around this way, that's one axis. It requires a certain amount of energy to go around that one line. If you go this way, it requires a certain amount of energy. But then when it's going this way, that energy is in the middle. So if this spinning requires a low amount of energy and that requires a lot of energy, this requires some energy that's in the middle. And so the forces that keep it stable when it spins are not there when it's going like this. So it gets out of hand. It spins around, and some minor little push is enough to get it to go off course. It starts spinning in a really wild way. And so this handle spinning in space, it doesn't have gravity to worry about. It doesn't have as much friction to worry about. So all that's happening is that instability. And you can see it gets really unstable. First, when it gets spun, it goes whoop, and then it goes vrang right away. But then it starts sort of flipping back and forth in a very unstable way. And that shows that intermediate axis theorem. So that's one major piece of weird motion that I wanted to show you. I have one more. So what I'm going to do now is share a different video. This video, let's see if I can bring it up. There we go. This video was made by John in our exhibits department, and I'll show this to you. Here we go. Beep. We'll show that again. Oh, come on. You can do it. Come on, little media player. Okay, the media player does not want to play. The media player is frozen. Wow. Technology. Okay, well, we saw in that video, John had a pendulum with a strong magnet at one end. He lifted it up, he dropped it, and the block at the other end, oh wow, okay, so the block at the other end, there it is made of copper. So when John lifts up that magnet and it swings toward the copper, what happens is there's a magnetic field around the magnet, and there's a little magnetic field that moving magnet puts into the copper, and so it ends up slowing down the magnet because that magnetic field that is induced in the copper slows down the magnet. And I showed you something like that a while ago with the magnetism video, where I had a copper tube and I dropped a neodymium magnet down it, and there was those eddy currents again of the magnetic field inducing a current into the copper pipe, which made a magnetic field, and that magnetic field slowed down the magnet. Same thing that happened with John's video. Well, Thank you very much for joining me today on Curiosity Corner Live. We have a challenge for you today. You can experiment with the intermediate axis theorem. Be careful. Don't want to drop anything. But some other things that you can explore. Look around you in the world around you and see if anything is moving in a weird way. And if you explore the intermediate axis theorem with something like a broom or a tennis racket, see if there's objects that don't follow it. For instance, this roll of tape. Would this roll of tape follow the intermediate axis theorem, the tennis racket effect, where it spins wildly if you spin it around the wrong line? So that's your challenge for today. Explore that tennis racket effect and explore things that move in weird ways around you. And with that, I will say thank you for joining us. And don't forget to check back tomorrow for more science content. My name is Andy, and stay curious.